Cambridge International AS and A-level Mathematics. Paper 3, Pure Mathematics 3, 2020. Answer all questions. The total mark for this paper is 75. You must show all necessary working clearly. Question number 1. Find the set of values of x for which 3 times 2 to the power 3x plus 1 is less than 8. Give your answer in a simplified exact form. The laws of logarithms. Log x to the base a plus log y to the base a is equal to log x times y. You multiply them. Multiplication law. Log x minus log y is equal to log x divided by y, the division law. And log x to the power k, the k comes to the front, is equals to k log x to the base a, the power law. So we're going to use this power law, and we're going to use the division law. So the first thing is 3 times that, you take 3 to the right hand side, it becomes divide. So it's 8 divided by 3. Now we're going to put natural log ln in front of both of them. So using the power law, 2x to the power 2 to the power 3x plus 1. The 3x plus 1 comes to the front. It becomes 3x plus 1 times ln 2 is less than ln 8 over 3. Now you can remove the brackets. 3x times ln 2 is 3x ln 2. 1 times ln 2 is 1 ln 2, and you just write ln 2 is less than ln 8 over 3. Now we take plus ln 2 to the right hand side, it becomes minus ln 2. So 3x ln 2 is less than ln 8 over 3 minus ln 2. Use the subtraction law, the division law. When you're multiplying them, when you're subtracting them, you divide. So it's ln 8 over 3 divided by 2. A division law. So 3x ln 2 is less than ln 4 over 3. Now it's times ln 2 on the left. If you take it to the right, it becomes divide by ln 2. So 3x is equals to ln 4 over 3 divided by ln 2. It's times 3 on the left. If you take times 3 on the left to the right, it becomes divide by 3. So x is less than ln 4 over 3 divided by 3 times ln 2. And this 3 can go to the front using this power law. So it becomes ln 4 over 3 divided by ln 2 cube. 2 cube is 8. So it becomes x is less than ln 4 over 3 divided by ln 8. Question number 2. Expand 1 plus 3x in ascending powers of x up to and including the term in x squared, simplifying the coefficients. So got 2a, I've got 2b. We're going to use the binomial expansion formula, and that's the formula there I've circled in the blue. N is minus 1 over 3. X is equal to 3x. So using that formula, we have 1 plus minus 1 over 3, which is our n. Our x is 3x. And then minus 1 over 3 is our n. Minus 1 over 3 minus 1 over 2 factorial times 3x squared. So simplifying that, you got 1 minus x plus 2x squared. Part B, state the set of values of x for which the expansion is valid. The expansion is valid for bx, absolute value of bx is less than 1. So absolute value of 3x is less than 1. You divide by 3, absolute value of x is less than 1 over 3. And absolute value of x is less than 1 over 3. Question 3. Sketch the graph of y equals to 2x minus 3. And then you go part B as well. So in the graphics calculator, you put in 2x minus 3. The x-axis goes from minus 10 up to plus 10. The y-axis goes from minus 10 up to plus 10. And that will give you the shape of the graph. And to find where it crosses this point there, G solve, you find that point there, the minimum point, and G solve on the graphics calculator, you find where it crosses the y-axis. X is 0, y is 3. Part B, solve the inequality. 3x minus 1 is greater than 2x minus 3. The graph in red is the line 3x minus 1. And you find where the meet at 4 over 5, 0.8. So when x is bigger than 0.8, that line is bigger than 2x minus 3. So that's your answer. X is bigger than 0.8. The line is above the blue line. So the red line is above the blue line when x is bigger than 0.8. Question number 4. The parametric equations of a curve are x equals to e to the 2t minus 3 and y equals to 4 ln t, where t is bigger than 0. When t is equals to a, the gradient of the curve is 2. Show that a satisfies the equation a is equals to half bracket 3 minus ln a. So this is the complete question 4. It's got part A, B, and C. Okay, so we want to differentiate x equals to e to the 2t minus 3. You differentiate 2t minus 3. Differentiate 2t, you get 2. Differentiate minus 3, you get 0. So it becomes 2 times e to the 2t minus 3. Y is equals to 4 ln t. dy over dt would be 4 times 1 over t. When you differentiate ln t, you get 1 over t. And we use dy over dx is dy over dt divided by dx over dt. So 4 over t divided by 2 e to the 2t minus 1. So you get that expression for dy over dx. Now we put t is equals to a. It says that t is equals to a. So we put t is equals to a and put dy over dx equals to 2. dy over dx is 2. T is equals to a. So put the 2 there and put a for t. So have 2 is equals to 4 over 2a e to the 2a minus 3. Which, if you cross multiply, will be 2 times 2, a e to the 2a minus 3 is equals to 4. The 2 times 2 is 4. It will cancel with that 4. So you got a e to the 2a minus 3 equals to 1. If you put ln in front, ln in front, ln in front, ln of 1 is 0. So if you bring, you can separate this, is ln a plus ln e to the 2a minus 1 is equal to 0. So ln a plus 2a minus 3 comes to the front. Ln e is equal to 0. Ln e is 1. So ln a plus 2a minus 3 equals to 0. So take 3 to the right, it becomes plus 3. Take ln A to the right, it becomes minus ln A. So 2A equals to 3 minus ln A, and you divide by 2. It becomes half brackets 3 minus ln A, which is what you're required to show. Part B, verify by calculation that this equation has a root between 1 and 2. So we want to calculate A minus half bracket 3 minus ln A when A is 1 and when A is 2. So how do we do that? We would have take all of this to the left side. So A minus half bracket 3 minus ln A equals to 0. Put A equals to 1. 1 minus a half bracket 3 minus ln 1. You get minus a half. Remember the sign there is minus. We put A is equals to 2. 2 minus a half bracket 3 minus ln 2. You get a positive answer, 0.8446. So there is a change of sign between 1 and 2. Therefore, there is a root when there's a change of sign. Part C, use the iterative formula A n plus 1 half bracket 3 minus ln A to calculate correct 2 decimal places, showing the results of each iteration to 4 decimal places. So that's the iteration formula there. Question number 5. Show that differential of x minus arctan x is equals to x squared over 1 plus x squared. And this part B there. To show that, we can use y to be equals to inverse tan x. So tan y, put tangent in front, Tan y is equals to tangent of inverse tan x. Tangent and inverse tan x will cancel, so you just get x. So tan y equals to x. Differential of tan y over dx is equals to differential of x over dx. When you differentiate tan y, you get sec squared y, and then you put dy over dx. Differentiate x with respect to dx, you get 1. So sec squared y times there goes to the right side, it becomes divide. So dy over dx is 1 divided by sec squared y. And you change sec squared y is as 1 plus tan squared y. So dy over dx is 1 over 1 plus tan squared y. But tan squared y is x. Tan squared y is x. So that will be 1 plus x squared. Remember, we're using this here. Cosine squared plus cos squared is equals to 1. If you divide all by cos squared, you get tan squared plus 1 is equals to sec squared. And you can use y instead. Tan squared y plus 1 equals to sec squared y. So tan squared y is the same as tan y all squared. They are the same. So that means differential of x minus inverse tan x. When you differentiate x, you get 1. Differentiate inverse tan x, you get 1 over 1 plus x squared. Put them as in the common denominator, 1 plus x squared. Will be 1 plus x squared there minus 1. So the 1 minus 1 will be 0. You get x squared over 1 plus x squared. Part B. Integral. Show that the integral from 0 to root 3 of x inverse tan x dx is equals to that. We're going to use integration by parts. So if we put u to be inverse tan x, du over dx is 1 over 1 plus x squared. We've done that earlier. The 1 over 1 plus x squared. If we put dv over dx is equals to x, dv would be x dx. An integral of dv will be integral of x dx. So v would be x squared over 2. Now put it together in the integration by parts formula. we have this inverse tan x times x over 2 minus x over 2 times 1 over 1 plus x squared. So now we take half out of the bracket. And then now to integrate this, we can split it as partial fractions. So we have x squared plus 1 over 1 plus x squared minus 1 over 1 plus x squared. So what we've done here, we've add 1 and minus 1. It doesn't change the fraction. If you add 1 and minus 1, it doesn't change the fraction. So that gives us x squared plus 1 over 1 plus x squared minus 1 over 1 plus x squared. Or you can do long division if you want. So what we're going to get here is 1. This will cancel. Minus 1 over 1 plus x squared. Now, when you integrate 1, you get x. When you integrate 1 over 1 plus x squared, you get inverse tan x. Substitute the values 0 and root 3. So 0 and root 3, which if you put root 3 there, root 3 there, root 3 there, root 3 there, you get this expression. When you simplify it, this 3 will cancel with that 3. And you end up with pi over 2 plus pi over 6 minus root 3 over 2. And you add them up, you get 2 pi over 3 minus root 3 over 2. Or you can write it as 2 pi over 3 minus a half root 3. So it's the same like what you wanted to show. Question number 6. It has got part A, part B, part C, and part D. The complex numbers 1 plus 3i and 4 plus 2i are denoted by u and v respectively. Find u divided by v in the form x plus iy, where x and y are real. So u is 1 plus 3i, v is 4 plus 2i. We multiply by the complex conjugate. So it's plus there, you change that to minus and minus. So you multiply by 4 minus 2i over 4 minus 2i. So we can do the numerator separately. 1 plus 3i times 4 minus 2i. So you expand it and you will get 10 plus 10i. And you do the denominator, 4 plus 2i times 4 minus 2i. It turns out to be 4 squared plus 2 squared, which will give you 20. Remember, I is equal to square root of minus 1. So I times I is square root of minus 1 times square root of minus 1, which will give you minus 1. That's why we got my I squared there, we got minus 1 there. Now you put the two together. You can put the denominator now is 20, and that's the numerator there. So it's 10 divided by 20 plus 10i divided by 20, which is a half plus a half I. Part B, state the argument of u over v. U over v is half plus a half I. The argument tangent of theta is half divided by half, which is 1. Inverse tangent of 1 is pi over 4 or 45 degrees. So the argument is pi over 4 or 0.785 radians or 45 degrees. In an argon diagram with origin O, the points A, B, and C represent the complex numbers u, v, and u minus v, respectively. State fully the geometrical relationship between OC and BA. Okay, the argument above, that the formula above shows you the argument. The argument is given by tan theta is equals to y over x. That's why we had half divided by a half. So that was there, which we did before, for you to get the argument. Now for this part C, we got A is 1 plus 3i and V is 4 plus 2i. So that's A there, 1 and then 3i. B is 4 and 2i, 4 and 2i in the imaginary axis, 4 in the real, 2 in the imaginary. So that's B. U minus V. So 1 plus 3i minus 4 plus 2i. 1 minus 4 is minus 3. 3 minus 2 is 1. So it's minus 3, 1. That's where it is. So OC and BA are equal in length. OC and BA are parallel or have the same direction. Show that angle AOB is equals to 1/4 pi radians. Angle AOB is the same as the argument of U minus the argument of V, which is argument of U divided by V. So U over V is half plus a half I. Tan theta is 1. So theta is inverse tan of 1. And the argument of that is 45 degrees. Question number 7. By first expanding cos x plus 45 degrees, express cos x plus 45 degrees minus root 2 sine x in the form r cos x plus alpha, where r is greater than 0 and 0 degrees is less than alpha less than 90. Give the value of r correct to 4 significant figures and the value of alpha correct to 2 decimal places. And then we have part B as well. So these are the formulas that we're going to use. So we're going to expand cos x plus alpha, cos x plus 45. That's cos x cos 45 minus sine x sine 45. So cos 45 is root 2 over 2. So that'll be root 2 over 2 cos x. Sine 45